Hi guys, welcome to another video, and today we are starting off a new session of quick wins, and the topic for today is algebra. Just for admin's sake, if you're new to the channel, please don't hesitate to subscribe and hit the notification bell so that whenever I post a video you are in the know. So what are quick wins? Quick wins are basically the type of questions that are easier to master and will ensure that you boost your marks when it comes to exam type questions, or when you are writing an exam or writing a test. Those are the type of questions that are easy to score and are easy to master. So today we are doing the algebra part of the quick wins questions. So just an outline of what we are going to do. So for our quick wins, we have solve for x by factorization, and usually that is the first question in your final exams or any formal test. We have a solve for x by factorizing a trinomial, taking out a common factor or difference of two squares. So that is the type of quick win question we have in algebra. The second type of quick win question we have in algebra, and which is also a recurring question, is solving for x using a quadratic equation. And the next type of question we have is inequalities, where we use a number line or a graph. Then the next recurring quick win question is solving for x in SURDS, and you remember that is the one where we have to square both sides and then substitute the x value to check which value is valid or invalid. And sometimes when we have an inequality or a root that occurs in both sides of the equation, then we have to let that root equal to k, so we use k method or square both sides. So that is also a recurring question and it's part of our quick wins. The last type of question that forms a part of our quick wins is our simultaneous equations, where we have to make the simpler equation and take one variable and make it the subject of the formula, and then we substitute into the next equation and then we find our values. So that is it with quick wins algebra. And out of the 23 to 25 marks, these type of questions occupy the majority. You might find that these quick wins maybe 20 or 17 marks, which is a huge majority, and hence I said that they are going to boost your marks. So let's go into the questions and find out how we can score our marks and make sure that we excel in the subject. Okay, so the first one, we have to solve for x by factorizing. So in the first question here, I have x squared minus 3x is equal to 4. So very simple here. We have a quadratic, and the reason why it's a quadratic, the leading term is has the exponent 2. So what we do here, whenever we see an exponent 2, when you see an exponent 2 here, what we do, we put the equation in standard form, so meaning everything must be equal to 0. So x squared minus 3x minus 4 is equal to 0, so that it becomes easier for us to factorize. So what I always tell my learners here in grade 12 or in grade 11, because we've already done quadratic formula, you shouldn't stress yourself by taking too much time looking for factors. just go straight to quadratic formula and make sure you substitute correctly, because you'll be awarded the same amount of marks. But now if it's easier for you, we know that we have to find the product factors of -4 that give you -3, which is x minus 4 x plus 1 is equal to 0, and therefore x is equal to 4 or x is equal to -1. Very simple there. But if you do struggle with finding product factors, my advice to you is to always use the quadratic formula. And as I say to my learners, press a calculator, so you need not to waste time when you have your calculator with you. The next question, x squared minus 3x is equal to 0. So very simple here. We see that this is not a trinomial, this is a binomial which has a common factor of x. So we take out the common factor, x minus 3 is equal to 0, then x is equal to 0 or x is equal to 3. So very simple also. And sometimes it happens that once you've factorized your x value here, your bracket here becomes a difference of 2 squares. So make sure that you also watch out for that. The third one, x squared is equal to 4. So what most people would do is to root both sides, and the square root of 4 is 2. And what they would forget here is that the square root of 4 is plus or minus 2. So the safest option I would advise is to stick to standard form. Now remember, standard form, everything must be equal to 0. So x squared minus 4 is equal to 0. And then here we see that there's a difference of 2 squares, because there's a perfect square and a perfect square and a minus sign in between. So we know we open 2 brackets, and then x then is plus 2 and minus 2. This will ensure that you have both values. So now x is equal to -2 or x is equal to 2. So making sure that you do stick to the fact that you have 2 values for x. Let's go to the next question. And the next question, we have to solve for x by a quadratic formula. And before we even start, let's write down the equation for the quadratic formula. So quadratic formula is quite easy. You do have it in the formula sheet. It's x is equal to minus b plus minus the root of b squared minus 4ac all over 2a. So very simple. And that's my trusted best friend. I know that when I don't even need to find product factors, I just substitute into my calculator and I will get the values of x. And I don't lose marks for doing that. So whichever topic I'm dealing with, whether it be sequence and series or functions, I know that quadratic formulas always works. So we have to solve for x here, and we have x squared, 2x squared minus 3x is equal to 4. And the key here is to write your equation in standard form. Remember, standard form is ax squared plus bx plus c is equal to 0. So what we have to do here is take 4 to the other side. So this will be 2x squared minus 3x minus 4 is equal to 0. Then we know that the value of a is 2, the value of b is -3, and the value of c is -4. So when we substitute into our equation here, I'll have negative, and then my value of b is -3 plus minus root, what is b? Negative 3 squared minus 4, and then the value of a is 2 and the value of c is negative 4, all over 2 times a is 2. And now remember, our calculators can't do plus or minus at the same time, so what we have to do is start with the plus, substitute with the plus, and then go change the sign. Don't rewrite everything, just move your cursor in your calculator so that you can change the plus sign to a minus so that you can save time. So if you substitute correctly in your calculator, you'll find that x is equal to 2,35, or x is equal to negative 0,85. So very simple there. We don't spend time with grouping or trying to find product factors. We just substitute into our calculator. Similarly, when we have the second one, this was a, and then we are doing b. 2x squared minus 4. Remember, your equation must be in standard form, so take 4 to the other side. 2x squared minus 4 is equal to 0. Now if you notice, this is not a trinomial. What this means is that a is equal to 2 because it's the coefficient of x squared, and because there's no value with a coefficient of x, then now b becomes 0, and then c is equal to negative 4. So you have to be smart there. If you look at your quadratic formula, the value of a is the number next to x squared, the value of b is the number next to x, and c is the constant which doesn't have an x next to it. So meaning that whenever you don't see a number next to x, then that value is 0. So now how do we substitute that into our quadratic equation? Okay, minus, and then the value of b we've established is 0, plus minus the square root of 0 squared minus 4 times, and then a is 2, c is negative 4 over 2 times, and then a is 2. And if you substitute correctly into your calculator, you'll find that x is equal to 1,41, or x is equal to negative 1,41. So very simple there. What we know that when we are using quadratic equation, the most important thing is substituting. And how do you substitute? You put your values in standard form, and your standard form is ax squared plus bx plus c. And if you don't see a value next to x squared, then it means a is 0. Or if you don't see a value next to x, then it means b is 0. Or if you don't see a constant, then it means that the constant is 0, and you substitute correctly. So let's move to another slide, and now we're doing inequalities. And with inequalities, the same story happens. You can do inequalities by factorizing, taking out a common factor, trinomial, difference of two squares, or using a quadratic equation. But now things are slightly different here, because you have to sketch or draw a diagram for your values, and you have to come up with an inequalities as an answer. So a, instead of x being one value or two values or three, x is an interval. So what we have to do here, we have the first one, x squared minus 3x is less than 4, and then we have to solve for x. So we treat this one similar to the equal sign, but it's an inequality and the answer is different. So this is a quadratic. The first thing that has to happen is standard form. 3x minus 4 is less than 0. So I've taken the 4 to the other side, and then now it's less than 0. And this will be very important when you're sketching your diagram. So now we have to factorize this, and this is going to be x plus 1, x minus 4 is less than 0. And instead of getting values, you are getting your critical points. So your critical points. Your critical points are the points that are going to allow you to sketch your diagram. My critical points is x is equal to -1 or x is equal to 4. Those are my critical points, and I'm going to sketch them here in my number line, starting with the smallest value, which is -1, and then going to 4. Now remember what I said. I said the greater than 0 is going to be important because this is a number line. Here's a trick that I found out. This is a number line and it continues indefinitely. But now you have to follow, in your inequalities, you have to follow the less than. Oh, I've been saying greater than, and in fact it's less than. So you have to follow the inequality. Every time when you are sketching these inequalities, make sure that your leading term is positive. So we are lucky enough that our leading term here is positive, and when we are sketching our diagram here, it looks like this. Fine. So now we need to write the inequality. So what I would like you to note is that every time when I show my learners is that because some of them struggle with inequalities, so what I always tell them is that follow the inequality. When the inequality is less than, you are going to shade the bottom part, and the less than inequality is facing this way. You just put x and your critical points, and it works like this every time, and you must make sure that your leading term is positive. Let's go to the next one. We have x squared minus 3x is less than or equal to 4. So now standard form, x squared minus 3x minus 4 is less than or equal to 0. And then our factors is x plus 1, x minus 4 less than or equal to 0, and then we have our critical points. So our critical points are x is equal to -1 or x is equal to 4. And remember, we start off with our number line and we put in our critical points, and now we sketch our diagram here. Fine. And I said you follow the inequality. So if your inequality says less than, you are going to highlight the bottom part, and now here is your inequality is less than, is looking this way. Just put x and your values here, but because there's an or equal to, you also include it here, and then you are done. Let's go to the next one. Same thing, but here we have to take out the common factor, and we have x minus 3. Then now it's greater than. So critical points, go straight to the critical points because you've already factorized you didn't put in standard form. So your critical points are going to be x is equal to 0 or x is equal to 3. So sketching here, so I have a 0, I have a 3, and because my inequality is greater than, I'm going to sketch the top part. I highlight the top part, and then I follow the greater than inequality is looking this way, and then I put x and my critical points. Very simple. Then the next one, we have x squared is greater or equal to 4. Standard form is the first thing that you do, so x squared minus 4 is greater or equal to 0, and we factorize plus 2 minus 2 greater or equal to 0, and then we have our critical points. X is equal to -2 or x is equal to 2. Then you sketch your number line, and the smallest value first, which is -2, and then we go to +2, and then we sketch our diagram here. And because our inequality is greater than, we're going to go above our number line, and our inequality is going to follow the greater than sign. So here is greater than, and we put x, and then now our critical points, and then because there's an or equal to, we put the or equal to. So very simple. Inequalities are very simple to understand. The first thing that you do, you solve them the same way you do when you are factorizing or solving for x, but instead of x values, you have your critical points. Now you place your critical points on the number line, and then you draw your diagram, but make sure that your values are, or your leading term is greater than 0, so meaning that x squared is positive. Let's come up with an example E. Okay, now let's have an example here, an example E, where the leading term is less than, the coefficient of the leading term is less than 0, meaning that x squared is negative. So it's negative x squared minus plus 5x and minus 6 is greater than 0. So what do we do in the case where our leading term has a coefficient which is negative? We are going to divide by negative across. So now meaning that this negative divided by negative is x squared minus 5x plus 6. Now if you divide an inequality by a negative, what would happen is that if the inequality is going to flip, so if this is greater than, it's going to flip and become less than, and then we factorize x minus 3 x minus 2 is less than 0, and then our critical points now, critical point is x is equal to 3 or x is equal to 2. So those are our critical points, and we form our inequality here, or our number line. The smallest is 2, and here's 3, and then we draw our graph here. And then now what we need to focus on is that our inequality is saying greater than, so we have to go above the number line, and then our inequality follows the greater than sign, so our greater than sign is facing this way, and then we have our x here, and then we include our critical point, so it's 2 and 3. And there you have it, quick wins, inequalities. So it's very simple. Inequalities are very simple. What you need to focus on first is that if you have x squared, your inequality has to be greater, less than, or equal to 0. So you put it in standard form as though you were dealing with an equation. So we treat our inequalities like an equation, but instead of values, we have to have a diagram which shows the interval. Now, how do we sketch the interval? Instead of your x values, you have your critical points. So you start with the number line, and after the number line, you're going to draw your diagram, which is a parabola. And when the inequality is less than, you shade the bottom part of your parabola. Remember, the parabola now is separated by a number line. If the inequality is less than or equal to, then you shade the bottom part. If it's greater than or equal to, you shade the top part of the parabola. And now when you are writing the inequalities, what you do, you follow the inequality. So if your inequality was greater than, remember, you are writing the interval, so you are going to write the two greater than signs and put an x in the middle and write your critical points. If it's less than, you write your two less than signs, put an x in the middle and write your critical points. So it's as easy as that. And there you have your 17 marks out of 20, or out of 23. 17 marks out of 23, which is a lot of marks. The next topic that is going to allow you to have a lot of marks is solving for x using SURDS. Solving for x using SURDS, remember in the beginning of the video we said that you focus on squaring both sides, and after squaring both sides we have to check and validify our values, because in most cases when we have two values, what would happen is that one of the values is going to be incorrect, and we have a mark for choosing the correct value. And also what we need to know is that when we have a value occurring twice, meaning that it's on two sides of the equal sign, we use K method. So we are going to go deeper into that when we have when we are doing these sets. So let's just go straight into the questions. Okay, fine. I have root x plus 3 is equal to 3. So a straightforward set, what we do, square both sides. Square both sides. Here I'll have x plus 3 because I'm just removing the square root, and then here I have 9, and then we just solve for x. So x is equal to 9, and then if you take thingy minus to the other side, it becomes negative. So 6 and 9 minus 3 is going to be 6. So x is 6, and then if we check, remember we had root x plus 3 is equal to 3. That's what we had, and we are saying that x is equal to 6, so it's going to be root 6 plus 3 is equal to 3. So 6 plus 3 is 9, and then the root of 9 is 3, so 3 is indeed equal to 3. Therefore x is equal to 6 is a solution. So very simple. And for the second one, we have x plus 3 minus x is equal to negative 3. So here is quite tricky because now we have to square both sides, but my advice to you is for you to isolate the root. I always tell my learners that they have to isolate the root. So what does that mean? It means the root must be on its own. Whether it's on the left or on the right, the root must be on its own. So meaning that the root x plus 3 should be, and then we take x to the other side, becomes positive, so x minus 3 should be on its own side. Can you see now the root is on its own, and now it's easier to square both sides, because this side I'll have x plus 3 is equal to, and then this side I have x squared minus 6x plus 9. So very important. And know that when we're squaring both sides and you're squaring a bracket, maybe I should take things slower. We are squaring a bracket here. So where does the x squared minus 6x come from? Because we're squaring this bracket, we are multiplying it by itself, so it's x minus 3, x minus 3. That's what we are doing essentially. So this is x plus 3, and then x times x, we're using FOIL method, it's x squared. X times negative 3 is negative 3x. X negative 3 times x is negative 3x, which are like terms, and that will be negative 6x. And then negative 3 times negative 3 is positive 9. So very simple there. And because we have an x squared, we make everything equal to 0. So what I'll do, I'll leave everything here and move the x plus 3. So it's x squared minus 6x plus 9. And if I take 3 to the other side, becomes negative 3, and then negative x is equal to 0. And now we add like terms. So when we're adding like terms here, I'll have x squared, and then minus 6 and minus x is negative 7x, and then 9 minus 3 is plus 6 is equal to 0. So very simple there. And if we look at our factors, is x minus 1 and x minus 6 is equal to 0. So I'll have x is equal to 1 or x is equal to 6. So now we have to check whether x minus 1 or x is equal to 1 or x is equal to 6 is a solution to the equation. So now what we have to do, remember our original equation was x root x plus 3 minus x should be equal to negative 3. And then if we substitute 1 here, this is going to be root of 1 plus 3 minus 3 is equal to negative 3. So quickly now, 1 plus 3 is 4, and the root of 4 is 2. So 2 minus 3 is negative 1, which is negative 3. So negative 1 is not equal to negative 3, so meaning x is equal to 1 is not a solution. And then we try out another one. We try out 6 now. Root of 6 plus 3 minus 6 is equal to negative 3. So 6 plus 3 is 9, and then the root of 9 is 3 minus 6. So 3 minus 6 is negative 3, which is negative 3. And then now x is equal to 6 is a solution. So meaning that now what you have to do here, you have to scratch off the 1, and then your answer is going to be 6. And the next one we have, I'm going to rewrite it here, root x plus 3 minus x is equal to 3. So over here now we are faced with the fact that the root is not on its own on the left hand side, and also the root has a coefficient. So what do we do in such a case? First of all, we have to fix the fact that the root is not on its own, so we are going to take x to the other side. So 2 root x plus 3 is equal to x minus 3. And some people would divide by 2, but for me it's complicating things. So what I would do is square both sides here. Square both sides. And now when I'm squaring both sides, something that we forget is that I'm also squaring the 2, but I'm removing the root, meaning that the root is multiplied by 2, and whenever I'm removing the root, whatever is left here, I must also multiply it by what was next to it, to the root. So first of all, when I square 2, I'll have 4, but when I'm squaring the root, I'll have x plus 3, but these two things were multiplied, so I write x plus 3 in a bracket. Then now I'll have to say x minus 3 multiplied by x minus 3, and on this side I have 4x plus 12 is equal to x squared minus 6x plus 9, and then the standard form of that is x squared minus 6x plus 9, and then take 4 to the other side, negative 4x, take negative 12 is equal to 0. Then if I add my like terms here, I'll be left with x squared minus or plus 2x, because these two are like terms, and x and negative 3, because these two are like terms, is equal to 0. And then when we factorize, x plus 3, x minus 1 will be our factors, and then x is equal to negative 3 or x is equal to 1. Those are our solutions, and then we have to check whether those solutions, which of those solutions are valid and invalid. So now our original equation was 2x plus 3, and then it's equal to 3, and then the first one we have to check is 1. So when we check 1, we have to substitute 2, and guys, I'm doing this manually. You guys, you can just substitute into your calculator and just do it quickly. So now, yeah, 1 plus 3 is 4, and then square root of 4 is 2. 2 times 2, that is 4, and then 4 minus 1 is 3. So here it is. So this is equal to 1 is a solution. And then we test the second one, root 2 root negative 3 plus 3 minus negative 3 is equal to 3. That's what we have to test. So now negative 3 plus 3 is 0, and then root of 0 is 0 multiplied, everything is 0 here, and then negative times positive here, negative times negative is positive, so 3 is equal to 3, and also x is equal to -3 is a solution. So sometimes it does happen, hence you have to check both of your values. Sometimes it does happen that both values are solutions. So what do you have to look out for here when we're talking about solve for x using SURDS? First thing, you have to isolate the surd. It must be on its own. The second thing that you must do, you have to square both sides. And then if the surd, so coming to the example I was wanting to show you, the one we were speaking about at the beginning of, so I'm going to use root x plus 3. So if we have, let's say for instance, root x plus 3 is equal to maybe 7 over root x plus 3 plus x. If you see the same root or surd in both sides of the equal sign, you have to use the K method. So what you are going to do is let root x plus 3 equal to k. So then now this is k is equal to 7 over k plus x, and this is going to be easier for you to solve. So whenever you see a root appearing on both sides of the equal sign, let it equal to k and solve it as though you're solving a quadratic. Last but not least, we have our simultaneous equations. So with simultaneous equations, your goal is to make sure that you have two equations. Here's my equation 1 and then here's my equation 2. And what you're going to do, you're going to pick between equation 1 and equation 2 which one is easier to manipulate and get one variable on its own. So now I'm picking equation 1 because I can easily take negative 3y to the other side, and then I'll have x is equal to 3y plus 1, which would be my equation 3 now. And then I would substitute it to the equation that I didn't manipulate, which is equation 2. So now wherever there's x in equation 2, I write 3y plus 1. So I have an x squared initially, so let me just write it: x squared plus 2xy minus y squared is equal to 23. So whenever I see an x, I put 3y plus 1. So it's 3y plus 1 squared plus 2, and then wherever there's an x, 3y plus 1 multiplied by y minus y squared is equal to 23. And this is going to be a bracket multiplied by itself, so I'll shorten that and I'll have okay, let me just do it. I'll have 3y plus 1 multiplied by 3y plus 1, and over here what I would essentially do, because we are multiplying, I can just put the y in front before I multiply so that I reduce my chances of making a mistake. Minus y squared is equal to 23. And then now FOIL method, this is going to be 9y squared, and then if I multiply my outer terms, I'll have 3y, inner term 3y, so it's plus 6y and then plus 1. And when I multiply here, going to distribute the 2y, so it's going to be plus 6y squared plus 2y minus y squared. And because I'm seeing a highest power or a highest exponent, which is 2, I'm going to make everything equal to 0. So yes, 23 is equal to 0. So very simple. And then now I'll add my like terms. So I have 3 values having a y squared. So I'll have 9 plus 6, it's 15, minus 1, that will be 14. So I have 14 y squared plus because I have 6y and 8y, so I'll have 6y and a 2y, so I'll have an 8y. And then if I add 1 and negative 23, I'll have negative 22 is equal to 0. And now comes our quadratic formula. We don't need to find product factors here. Just substitute y is equal to minus, then my b is 8 plus minus the root of 8 squared minus 4, and then a is 14, and then c is negative 22 over 2 times 14. So y is equal to 1, or y is equal to negative 11 over 7. So because we've established that x is equal to 3y plus 1, so I'll have, if y is equal to 1, I'll have x is equal to 1 plus 1, which now equals 4. And then if x still is equation 3, then I'll have 3 times negative 11 over 7 plus 1, which is equal to negative 26 over 7. So I've solved for x and y simultaneously. First, I took the easiest equation to manipulate, and I saw that if I can just leave this x here and take the negative y to the other side, I can have my equation 3. And then I substitute my equation 3 into equation 2, and then I simplify until I get my y values. Once I get my y values, I can just substitute them and get x. Let's look at another example of simultaneous equations, and this one involves exponents. Okay, fine. So equation 1 is 2 to the exponent x minus 1 is equal to 8 to the exponent y, and I have my equation 2 here. So the easiest one to manipulate is still equation 1, because what I can do here, 2x minus 1 is equal to 8 to the exponent y, but I can see that these are powers of 2, so I'll write them as powers of 2. I'll have 2 to the exponent x minus 1 is equal to 2 to the exponent 3, and then here's the y, and then apply my laws of exponents, and then I will multiply. Here it is 2 to the exponent 3y, and then now I have the same base, which is 2, and I equate my exponent. X minus 1 is equal to 3y, and then x is equal to 3y plus 1. And it seems like this is equation 3, and it seems like it's the same as the last question, but we'll do it either way. So remember what we have to do. We substitute equation 3 into 2, but equation 2 is x squared plus 2xy minus y squared is equal to 23, and then wherever we see x, we substitute 3y plus 1, and in this case is squared, plus 3y plus 1 multiplied by y minus y squared is equal to 23. And now we know that, okay, this is going to be distributed. We're going to write this twice, and over here we have to put the y in front and distribute the 2y, and then collect like terms. Once we have collected like terms, we'll get that 14y squared plus 8y minus 22 is equal to 0, and that would be our standard form. And if we substitute into our quadratic equation, we get that y is equal to 1, or y is equal to negative 11 over 7. And if y is equal to 1, then x is equal to 4, and if y is equal to negative 11 over 27, then x is equal to negative 26 over 7. And that's it from my part with the algebra. And remember guys, if you revise these types of questions, there's no way that you won't get the majority of the marks when it comes to question 1 in any of the final exams, whether it be prelims or what. When it comes to question 1 and when it comes to algebra, these are quick wins for a reason. They make these types of questions are easy to score questions, and they ensure that you get maximum marks when it comes to the specific topic. And from my side, it's a goodbye for me, and hopefully you'll see me in the next video when I do the same quick wins with a different topic. I think the next video will be with sequencing series, and I hope you will benefit a lot. And please like, comment and subscribe, and click on the notification bell so that you are notified whenever I post a video. I'll see you on the next video, and remember, we are doing sequencing series and focusing on the quick wins.